My name is Evelyn, and today I'm going to talk about build and replication of Docker images at Uber. A little bit about me. I graduated from UCLA with a bachelor degree of CS, and Uber is my first job. I've been on cluster management for almost 2 years. So today I'm going to talk about what is Docker and why we use Docker at Uber. How do you increase the efficiency of building Docker images? And how do we increase scalability of distributing Docker images? So what is Docker? Docker is an open source project that provides OS level virtualizations. When you launch a Docker image, it creates an isolated environment where all your runtime change will not be applied to the host file system. At Uber, we manage thousands of microservices, and each of them has its own Docker image. At Uber, we choose Docker because Docker containers are relatively lightweight and easier to manage in a shared cluster. So let's dive a little deeper into what's inside a Docker image. When you open up a Docker image, you'll see a bunch of tars. Those we call Docker image layers. And when you untar the layers, you just see it's just a bunch of directories and files, which looks very much like your host file system. So how does Docker create such image? When you initiate Docker build command, for each line in your Docker file, Docker daemon will create a container, run a command, and commit it as layers. So in this example, we have install vim in the first command. So Docker daemon will create container 1 and run install vim and tar the result and save as layer 1. And the second command is make. So Docker daemon will create another container, run make, and tar the result as layer 2. Same thing for layer 3. So how do we use Docker at Uber? Our team managed 2 services, one called uBuild, the other called Docker Registry. They are part of a larger deployment system. So we have an end user. It's going to go to a website and click a button, create build, and uBuild will create a Docker image and then push to Docker registry. Our scheduling framework will then schedule each host to pull Docker image from the registry. Currently, we support thousands of build requests and millions of image pull requests per day. And for each week, we generate 2T new images. So let's talk about uBuild first. Now, we've seen a few issues with regard to building Docker image with native Docker daemon. The first one is we're actually running a forked Docker daemon version in our cluster because it doesn't have build-time mount. It also doesn't have build-time net options. And another thing we realized is native Docker daemon doesn't really have very good performance. It doesn't have distributed cache. It creates high disk I/O. And our average build time range from 5 minutes to 30 minutes. Sometimes I've seen 40 plus for build time, which is not good for our customers. And it creates large images. Our average image size range from 500 megabytes to 1 G. I've seen 6 to 8 G. Sometimes there are 20 G images. And finally, since we have this forked Docker daemon, we'll have to run in a dedicated cluster, which increases operation load on our team. So how do we increase the efficiency of building Docker images? So on the left, you can see this is our old way. Basically, uBuild will basically shell out to Docker daemon. Docker daemon will create a Docker image for us. So with our new solution, we want to run everything inside one single container. With the same example, we have install vim. After that, we tar the vim as layer 1. And within the same container, we run make. And then we tar the binary as layer 2. Same thing for layer 3. This way, we reduce the overhead of creating and tearing down containers, which reduce our build time. Another thing we noticed is not all the layers are used during runtime. So for example, if we don't use vim at runtime, we don't have to generate 3 layers and put it into the final image. So instead of 3 layers, we have layer 2 and layer 3, which reduce our image size. And on top of that, since we control the committing and pushing of Docker image layers, we can build distributed cache relatively easily. And finally, since we got rid of the dependency on Docker daemon, uBuild can now run in a shared cluster where Docker daemon is not necessarily installed. So here's our result. In comparison, as you can see, our build time is decreased by half, and our build image is decreased by almost half. So this is a good progress for us. Now let's talk about registry. So this is a close-up look of our current setup. Basically, you can see all the hosts in the cluster are connecting to this single component. And as our cluster size increase, this model wouldn't scale. So here are the Docker registry problems. So first one is network bandwidth. For each of our Docker registry hosts, we currently have 10G NIC limit. And with that, we need to support thousands of concurrent requests. It also creates high disk I/O because when you pull and push image from Docker registry, registry will hash the image content. So how do we increase the scalability of Docker registry? So the first solution we tried is to use cache. Basically, we insert a cache between the cluster nodes and Docker registry, but soon we realized that this doesn't work. We actually had an outage with this when we tried to do a cluster maintenance, and then we tried to put 200 different images from the cache, which busted our cache and basically lost the Docker registry. So this doesn't work. So the second solution we have is to leverage peer-to-peer network. As you can see, we install peer-to-peer agent on each host, and the idea is the hosts within the cluster can talk to each other and download image from each other instead of all connecting to the central component. So here's our benchmark. With 2,000 nodes, we can easily download 1G file within 10 seconds. And here's a short simulation. As you can see, the blue dots are the old original Docker registry hosts. They are the seeders in our peer-to-peer network. And as the nodes in cluster join, they start to form connection with each other, and they turn yellow as they download the image. After they download the image, they turn green and close connection with each other. So we found this way reduce the load on Docker registry and at the same time reduce the distribution speed of Docker image across the cluster. So to summarize what I talked about, we talked about Docker. Docker is an open source project, provides OS level virtualization. We run Dockerized microservices in shared cluster as Uber. The old way of using Docker daemon to create image creates large artifacts, and with our new way, we're able to generate smaller Docker compatible image within less time. And finally, we experiment with peer-to-peer network to distribute Docker image, which increase our scalability of Docker registry. All right, that's it. Thank you.